Welcome to the second marathon for differential equations. This is more about practical situations that we have in differential equations. And as I go on, I will be solving a range of questions. It says a certain substance is formed. In a chemical reaction, the mass of substance formed t seconds after the start of the reaction is x grams. At any time, the rate of formation of the substance is proportional to 20 minus x. So I can say that dx over dt is equal to k times 20 minus x. X is the substance being formed. It says show that x and t satisfy this differential equation. So I'm going to take dx over dt as 1 and x is 0. So that gives me k as 1 over 20, which is 0.05. So I've proved to you that is a differential equation that I'm getting as well. Dx over dt equals to 0.05, 20 minus x. Then part 2 says find in any form the solution of the differential equation. So it's any form. So I am going to bring 20 minus x to this side and say that this is dx and 0.05 dt. I'm going to integrate on both sides and say that this becomes ln 20 minus x divided by minus 1 equals to 0.05 t plus c. Then when x equals to 0, t equals to 0 as well, so this becomes minus ln 20 and this vanishes, so my c is minus ln 20. So the solution to my differential equation is minus ln 20 minus x equals to 0.05 t minus ln 20. Since it can be in any form, that is the form that I'm going to leave it in. Then it says find x when t equals to 10, giving your answer correct to 1 decimal place. Okay, so part 3 says that I need to find x when t equals to 10. So minus ln 20 minus x equals to 0.05 into 10 minus ln 20. Okay, so I think I'm going to just evaluate on a calculator. I know that at the end of the day I am supposed to evaluate correct to 1 decimal place. So minus ln 20 minus x equals to minus 2.4957. I can take an exponential of 2.4957. So 20 minus x gives me e power 2.4957, and then I can subtract this from 20 and say that x should equal 7.869, which is 7.9 correct to 1 decimal place. State what happens to the value of x as t becomes very large. Now for these questions it's best to have the exponential the differential equation in the form of x. So what I'm going to do is I'm going to first try to express this um, in the form x equals to something. I'll make x the subject. It's difficult to predict this unless you have x as the subject, because I need to make t very large, and I don't think that's going to work with x without x as the subject. So this becomes ln 20 minus ln 20 minus x equals to 0.05 t. This becomes ln 20 over 20 minus x. This becomes 20 over 20 minus x equals to e power 0.05 t. Okay, cross multiplication. Okay, then making x as the subject. Although this is just a 1 mark question, but because I didn't do this process earlier on, this is what the question asks me to do. So x is basically 20 e power 0.05 t minus 20 over e power 0.05 t. Now the one way of doing it is to take a large value of t and put it here in the expression, but sometimes your calculator will give you an error, so we'll just have to be careful about that. If it gives me an error, I'll take a smaller value of t and try to work with that. Right now I am putting the value 1000, so that e power 50 is what I get If that doesn't work out, I'm going to reduce the power and see if I get the correct answer. Yeah, when I put in 1000 as t, that's a large value for t, x turns out to 20. So I'm going to say that x approaches 20 as t grows large. And as previously discussed in a video, I've told you this, that you can see that the largest impact in the numerator is from this term and the largest impact from the denominator is from this term. So essentially these cancel out and you're left with 20 over 1, that gives you 20. You actually ignore this term that is being subtracted because it doesn't have a very large impact. Moving on to question 2, this is something that's also part of the lectures, but I'm going to solve this again. This is a tough question. It says a tank containing water in the form of a hemisphere. The axis is vertical, the lowest point is A, and the radius is R as shown in the diagram. The depth of the water at time t is H. At time t0, the tank is full and the depth of the water is R. So at time 0, H is equals to R. An important conclusion later on: at this instant, a tap at A is open and water begins to flow out. So when water begins to flow out, it's dV over dt. What is that? At a rate proportional to root h. So since it's flowing out, it's minus k root h. Okay, the tank becomes empty at time t equals to 14. So at t equals to 14, I have v equals to 0 and h also equals to 0. Remember that r is the radius of the bowl and that isn't changing. Okay, the volume of water in the tank is v when the depth is h. It is given that v is by that formula. Okay, so show that h and t satisfy this equation. Now if I have to come up with dh over dt, I only have dv over dt. So my task here will be to apply the chain rule in such a way that I get dh over dt out of it. So I can see this. Can I simplify this first and say that this is 3 pi r h square over 3 minus pi h cube over 3? And then can I also differentiate this and get dv over dh, 2 pi rh minus 3 pi h square over 3. So that gives me pi h squared. Okay, now since I have dv over dh and I have dv over dt, can I construct a chain rule for myself? That's dv over dt over dh over dt. That is how I construct the chain rule. You might know it in a different way, and you should go on and apply the different way that you really know. Okay, 2 pi rh minus pi h squared dv over dt is minus k root h. I cannot find k right now because I don't have any rate given as a number. So dh over dt is basically minus k root h over 2 pi rh minus pi h squared. Now when I go on and see my form, it doesn't resemble anything that I have here. And the reason is I have a root h in the denominator and the answer doesn't. So what I'm going to do is, let me just take this down with me and I'm going to try to create that form now. I am going to say that I can say that this is basically h power half. Can I now say that instead of wanting this in the numerator, I want this in the denominator? So I'm going to bring it down and this changes the sign of uh, the function, sign of the variable. Okay, a sign of the power basically. So when I multiply this power inside, I know that I have 2 pi r h power 1. So h power 1 multiplied by h power minus half will get the power subtracted and I'll end up with h power half. And here I'll end up with the power 2 minus half, which is 3 over 2. So I've multiplied the powers inside, multiplied the variable inside, which causes a decrease in the powers because it was h power minus half. Now I also notice that there's no pi here. So what I can do is I can take a pi common, 2r h power half minus h power 3 over 2, and I can put it in the numerator like that. because this question is open with regards to the numerator. It says you just need a b, where b is a positive constant and there's a minus outside. So I can say that k was a constant of proportionality, pi is basically 3.142. So it's going to, at the end of the day, give me a positive answer. Okay, so I actually have my form that I wanted in the question. My value for b is minus k over h, but the question doesn't really require you to find the value of b. Solve the differential equation. Now this is very important. If I've asked you for a particular form and I've given you the form in the question, it's best to just use that form rather than use your own form and then try to integrate. So I'm regardless of whether I solved part A correctly or not, I can still do part B correctly by saying that I just need to shuffle around the terms and write dh and minus b dt. I am going to integrate. So I'm integrating with regards to h, so r remains as it is. Okay, that's integrated, minus bt plus c. And this becomes 2 over 3 into 2rh power 3 over 2 and 2h 5 over 2 over 5 equals to minus bt plus c. Now I have two unknowns, which means that I must have two sets of informations. One of the sets of information is that when t is equals to 14, v equals to 0 and h equals to 0. So I can say that 4h power 3 over 2 over 3, h equals to 0. Okay, so 0 power 3 over 2 over 3, 0 power 5 over 2 over 5 equals to minus 14b plus c. So these are all 0 and I don't have c, so, or b, so c is basically 14b. Okay, that's fine. Let's try to do this again and say that I now need to plug in the value. I need another set. Now notice that at the start of the question, when I was noting down my information, I had also written down that there was another piece of information that when t equals to 0, h equals to r. So I have another set of coordinates. What that is doing is expressing in everything in terms of r, but let's see if that works out for us. To r minus b into 0 plus c. So I get 4 over 3 r power 5 over 2 minus 2r power 5 over 2 over 5 equals to c. Is that solvable? Yes, both have the same power. I can just subtract them. 14 over 15. 14 over 15 r power 5 over 2 equals to c. If I have c, then I should also have b. C was just 14b, so 14 over 15 r power 5 over 2 equals to b, 14b. So b is basically r power 15 5 over 2 over 15. It's a very complicated expression. Let's put everything to perspective and say that this was the integral that we got. Let's replace the unknowns that we've just found. So I found b and c. Okay, then what I needed was an expression for t in terms of h and r. So I need to make t the subject. So I am first going to bring the other term to this side. Okay, and then I'm going to say that if I want to make t the subject, then I can do this. Now, to be honest, that is a perfectly fine answer. This answer here in the marking scheme can be derived, and let's just quickly derive that. All of these terms will get multiplied by 15 over r power 5 over 2, so that's going to give me minus 60 r h power 3 over 2 divided by 3 r power 5 over 2 plus 30 h power 5 over 2 over 5 r power 5 over 2 and minus plus 15 into 14 r power 5 over 2 over 15 r power 5 over 2 equals to t. So this cancels out with that, 15 cancels out with 15, so I have 14 here. I have 6 and h over r power 5 over 2 as a common power equals to t, and I have 20 minus 20, powers of r get subtracted, and what I have is h power 3 over 2 divided by r power 3 over 2. 5 over 2 minus 1, there's 1 in the numerator for power of r. Okay, so I have my answer in the required, the one that's given in the marking scheme. Tough question. Moving on to the next one, it says naturalists are managing a wildlife reserve to increase the number of plants of a rare species. The number of plants at time t years is denoted by n, where n is treated as a continuous variable. It is given that the rate of increase of n with respect to t is proportional to n minus 50. So k n minus 150. Write down a differential equation and a constant of proportionality. So that's what I've done. It says initially when t equals to 0, the number of plants is 650 at a time. It was noted that at a time when there were 900 plants, the number of plants was increasing at a rate of 60 per year. So this is the value of dn over dt. And this was the number of plants. So I can find out k first, and then I can integrate and then find out whatever is left over. I can say that 60 equals to k 900 minus 150. I get 0.08. Then I'm going to try to integrate this. Um, 1 over n minus 150. This is part 2 that I'm doing. The part 2 started here actually. dn and dt. Okay, then integrating both sides, I get ln n minus 150 equals to 0.08 t plus c. Expressing n in terms of t. C, I just need to find c first. It's when t is 0, the number of plants was 650. So 650 minus 150, that's 500. So I get c as ln 500. Okay, then when I have c as ln 500, I can then make n the subject, and bring the ln terms on one side. Okay, reverse the ln, and I get 500 e power 0.08 t, n equals to 500 e power 0.08 t plus 150. Let's see if that is correct. Yes, that is correct. It says the naturalists are targeting the number of plants from 650 to 2000 within 15 years. Will this target be met? Let's see what our model tells us about 15 years. I am going to put in n as 15 and see on my calculator if I get the correct answer. I am getting 1810. So no, the target will not be met. Okay. Question number 4. It says in the diagram the tangent to the curve at a general point P with coordinates this meets the x-axis at T and the point N lies on the x-axis such that Pn is perpendicular to the x-axis. So this point is x comma y. The curve is such that for all values of x in the interval, the area of Ptn is equals to tan x. So tan x, where x is in radians, using the fact that the gradient of the curve at P dy by dx is Pn over Tn. Okay. Show that dy over dx equals to half y square cot x. So complicated question. Let's think about this. Now I know that Pn is going to be y because this is the y coordinate and it had the value xy, so this is y. This on is going to be x, so I know nothing about Tn for now. Let's see how I can get rid of Tn. I'm going to say that the area of this triangle is Pn into Tn divided by 2 equals to tan x. Now Pn is y, so I know that Tn is basically 2 tan x over y. Okay, let's see what you have on the other side. I have dy over dx equals to Pn over Tn. I already know that Pn is going to be y, and I also have Tn in terms of y. Can I write that with the reciprocal and say that dy over dx is this? Now, taking advantage of that, I'm going to say that this becomes y square over 2 tan x. 1 over tan x, so the reciprocal of tan x is cot x. So this becomes half y square cot x. So I've proved the first part for 3 marks. Then says given that y equals to 2 and x equals to this, solve this differential equation to find this equation of the curve expressing y in terms of x. So now I know I have to do differential equations. So I'm going to, since 2 bothers me there, a denominator bothers me with a number, a fraction basically. So I always move it to the right hand side. You could keep it on the left hand side as well. If you remember the integration of cot x, it's always ln sin x. The integral of just tan x is minus ln cos x. Those are both derived through integration by recognition, if you know that. But if you don't, just learn them. And this becomes minus 2 plus 1 over minus 1. So I have minus 2 over y equals to ln sin x plus c. So y equals to 2 when x equals to pi over 6 plus c. So minus 1 ln half. Sin pi over 6 is half. So that's minus ln 2. Ln half is basically ln 1 minus ln 2, if you don't know that. So c is basically minus 1 plus ln 2. ln 1 is 0. Okay, then I need to express y in terms of x. That's minus 2 over y ln sin x plus ln 2 minus 1. Just taking this negative sign on the other side, I get 2 over y equals to minus ln sin x minus ln 2 minus 1 plus 1. So that gives me 2 over y, and I can say that I have a minus common here. Okay, I should have done that first. Let's just not shift signs right now and just do that. Okay, it's easier to explain. ln 2 sin x and minus 1. Okay, to make y the subject, I need to shuffle things around. So this is ln 2 sin x minus 1. equals to y. That's a perfectly fine answer. This just has signs reversed. Why? Because they've taken the numerator to be positive as well. Okay, moving on to the next question. This is question number 5. It says the tank containing water is in the form of a cone with vertex C. The axis is vertical. I hope there was no other part to it. Yes, there wasn't. The vertical and the semi-vertical angle is 60 degrees. At time t0, the tank is full and the depth of water is h. So small h is equals to capital H. At this instant, the tap C is opened and water begins to flow out. The volume of water in the tank decreases at a rate proportional to H. So dV over dt is equals to minus K root H like before. Okay, where H is the depth of the water, time t, the tank becomes empty. So V equals to 0, H equals to 0, and T equals to 60. Show that H and T satisfy the differential equation. Now again, I have dv over dt and I need dh over dt, which means that I must connect them to a chain rule. Now there's something at the end of the question as well. It says the volume V of a cone of a vertical height h and base radius r is given by this. So can I say that the volume of the water is also in the form of a cone? So right now the volume of the water is 1 over 3 pi r square h, but I don't have r here. Okay, so that's a little problematic because I can't use that in a formula if I don't have it. Can I still say that I can connect this as h? I can say that tan 60, why don't I make it on the other side? Tan 60 is equals to r over h. So h tan 60 is equals to r. What is tan 60 on my calculator? Tan 60 on my calculator is root 3. So I get h root 3 equals to r. Okay, pi h square into 3 over 3 h cubed, sorry, h cubed. Okay, so volume of water right now is pi h cubed, which is interesting. Okay, let's do that. So pi h cubed over 3, pi h cubed is v. Can I calculate dv over dh? That's 3 pi h squared. Okay, then using the chain rule, dv over dh equals to dv over dt dh over dt. So 3 pi h squared dv over dt is minus k root h. dh over dt is unknown. So dh over dt equals to minus k root h, 3 pi h squared. I can see the power is cancelling out. So minus k over 3 pi, and this becomes h power half minus 2. So minus k over 3 pi, h power minus 3 over 2. Then part 2 says solve this differential equation given in part 1. So I'm going to use this equation that's given in part 1. I'm not going to use my own because that had k in it, and the proof didn't have k in it. It had an a because it was compressing k over 3 pi into a. So 1 over h power minus 3 over 2 dh and minus a dt. So this becomes h power 3 over 2 dh and minus a dt. I integrate both sides. At h power 5 over 2 divided by 5 over 2 and minus 80 plus c. Now I have two sets of information, t60 when h is 0. So let's use that one first. Let's call this 2 over 5. So c is 60a. Okay, then I use the other set of coordinates, that T is H, small h is capital H. Okay, small h is capital H when T is 0. Okay, so C is equals to 2 over 5 h power 5 over 2. So then expressing this as an equation, I get 2 h power 5 over 2 equals to minus a 24 h power 5 over 2 t plus 2 over 5 h power 5 over 2. I need to make t the subject, t in terms of h. So I am going to bring both these terms to one side. Capital H power 5 over 2 equals to 24 h power 5 over 2 t. So when I have t, this becomes 2 h power 5 over 2, 24. I may have made a mistake somewhere. Okay, this is not 2 over 5. I've substituted the values wrong, I imagine. Yeah, I have done some mistake here. Let's correct that first. Okay, so C was this, 60A equals to C. So A is basically 2 over 150 h power 5 over 2. 1 over 150. So that's 2 over 300. Okay, so A is that. I did make a mistake. That's 1 over 150. That's 2 over 5 h power 5 over 2. I hope I fixed the mistake. 1 over 50. 50. Okay, so when I bring 1 over 150 to this side, so that becomes 150 divided by h power 5 over 2, and 2 into 150 by h power 5 over 2 equals to t. So this cancels out with that. This gives me 60 equals to t, and 60 h over capital H power 5 over 2. I think I've forgotten the minus यहाँ पे. This is minus t, so that gives me t equals to 60 minus 60 h small h or capital H by 5 over 2. Very complicated sort of expression. Then it says find the time at which the depth of the water reaches half h. Okay, half of height. Time equals to 60 minus 60, half capital H over capital H. Okay, so H and H cancel out. 60 minus 60, half power 5 over 2. So 60 into 0.5 power 2.5. 60 minus answer, and that gives me 49.39. 49.4. That is the end of this question. Okay, so the next question is, it says in a chemical reaction, a compound X is formed from a compound Y. The masses in grams of X and Y present after the start of the reaction are X and Y respectively. The sum of the two masses is equals to 100 throughout the reaction. So X plus Y is always equals to 100. The rate of formation of X is proportional uh, to the mass of Y at the time. So dx over dt is basically proportional to the mass of y at that time. So I'm going to write equals to ky. Okay, when t equals to 0, dx over dt equals to this, show that x satisfies the differential equation. Now, since x plus y is always equals to 100, can I write dx over dt equals to k times 100 minus x? Y is basically 100 minus x. Okay, so moving to the next step, then I need to find out k, so that's 1.9. K is the unknown here, 100 minus 5. So it's 1.9 divided by 95, and that should give us the final answer. That is k is equals to 0.02. So dx over dt is therefore 0.02 times 100 minus x. That's the first part, an easy 2 marks. Solve this differential equation. So I'm going to bring in 100 minus x here and say dx and 0.02 dt. Okay, that's part 2 that I'm doing. That was part 1. Integrating both sides gives me ln 100 minus x equals to ln 0.02 dt. Oh no, sorry, not ln 0.02, it's 0.02 t plus c. This is divided by minus 1 because ln 100 minus x divided by minus 1. Then I have x5 when t is 0. x5 when t is 0. So c is basically minus ln 95. For x in terms of t, so minus ln 100 minus x, 0.02 t plus c, and c is basically minus ln 95, so I'm going to write minus ln 95. This is ln 95 minus ln 100 minus x. Ln 95 over 100 minus x. 95 over 100 minus x equals to e power 0.02 t, and 95 over e power 0.02 t equals to 100 minus x. So x is therefore 100 minus 95 over e power 0.02 t. Then the next part is something about t growing large. What happens to the value as t becomes very large? So I can do that from a calculator, take a reasonable value for t, and that should give me the answer, and that should be 100. Why? Because you see, the second term has the denominator as an exponential. So let's say I take t as 1000, it comes, I need to make it larger, I think, 10,000. Okay, so it comes out to 100 exact. Why? Because this term eventually goes down to 0 when the denominator is very large. So anything over an infinite value is basically 0. So 100 minus 0 gives me 100. So x approaches 100. 100 as t grows large. T grows large. Okay. Question 7. A model for the height of a certain type of tree at time t years after being planted assumes that while the tree is growing, the rate of increase of height. Okay, so rate of increase of height is k times 9 minus h power 1/3. It is given that t equals to 0 when h equals to 1 and dh over dt equals to 0.2. Show that h and t satisfy this differential equation. So 0.2 k times 9 minus h should be 1 in this case, power 1/3. So 8 power 1/3 gives me 2. So k is therefore 0.1. So that proves the differential equation. And I'm going to start part 2 then. Dh over dt equals to 0.1, 9 minus h power 1/3. So says solve this differential equation, obtaining an expression for h in terms of t. So bringing this to this side, 9 minus h power 1/3 dh equals to 0.1 dt. I'm going to integrate. This is a simple integration. I'll take it up. The power becomes minus 1/3. I add plus 1. The power becomes 2/3 into minus 1. Okay, so that becomes minus 3 over 2. 9 minus h power 2/3 0.1 t plus c. So h is equals to 1 when t equals to 0. So this becomes 0, h equals to 1. So what does that give me? So minus 1.5 into 8 power 2/3. That gives me minus 6 equals to c. So I have 9 minus h power 2/3 with minus 3 over 2 outside equals to zero point 0.1 t minus 6. I need h in terms of t, so I'm going to try to make h the subject. I'm going to first remove this 2/3 minus 3 over 2, so that becomes minus 2 over 3 into zero point 0.1 t minus 2 over 3. Okay, so that becomes plus 2 over 3 into 6. Okay, I've taken a reciprocal with both. Basically what I've done is, if I were to just write it as something easier to understand, this is what I've done. Okay, then I'll open up the bracket. 2 times zero point 0.1 divided by 3 is 2 times zero point 0.1 divided by 3 gives me 1/15th. 1/15th minus 1/15th t plus 4. So that's 9 minus h power 2/3. Now, how do we remove power 2/3? The power 2/3 will become 3 divided by 2 when it goes to the other side. Okay, basically the reverse of a cube root is a cube and the reverse of a square is a square root, so that is why the answer is 3 over 2. So I get 9 minus 4 minus t over 15 power 3 over 2 equals to h. I hope that's the correct answer. Yes, that is the correct answer. Find the maximum height of the tree and the time taken to reach its height after planting. So the maximum height of the tree is when dh over dt should equal 0. That is something that's different from the previous parts. What I'm going to do is I'm going to say that this is basically equals to 0. So 0.19 minus h power 1/3 equals to 0. So 9 minus h is equals to power 1/3 equals to 0. So I cube both sides. That still keeps it 0. Nothing changes. So 9 minus h equals to 0. H equals to 9. So that's the maximum height. Something that you learn at in AS level. And the time taken to reach the ground. So if I have h as 9 and I want to find t, I'm going to have to pick up one of the forms of the equation and I will have to try to solve it. So why don't I just pick up this form that I had, minus 3 over 2, 9 minus 9 power 2/3 equals to 0.1 t minus 6. Okay, so that gives me 9 minus 9 gives me 0, and 6 divided by 0.1 gives me 60. Okay, then calculate the time taken to reach half the maximum height. So I think, and that is simple. I can just do part 4 minus 3 over 2, 9 minus 4.5, that's half the maximum height, power 2/3 equals to 0.1 t minus 6. 9 minus 4.5 power 2/3 into minus 1.5, 32 plus 6. So 0.1 t is 1.911. T is therefore 19.11. That should be the right answer. Yes, 19.11 years, not seconds, years. Okay. Question 8. The temperature of a quantity of a liquid at time t0. The liquid is cooling at an atmosphere whose temperature is constant and equal to A. The rate of decrease of theta is proportional to the temperature difference theta minus a. Does theta and t satisfy the differential equation? This they've already told you that. That's interesting that they don't want you to prove it or something. Find in any form the solution of the differential equation given that theta equals to 4a when t equals to 0. Do I have k? No, I don't have k. My answer should still contain k. Then I will bring theta minus a to this side. This is just about solving the differential equation, which means that it's about integrating. D theta equals to minus k dt. Put an integral on both sides. Ln theta minus a over 1. It's not minus 1 because a is a constant. Get differentiated to 0. Minus kt plus c. So theta equals to 4a when t equals to 0. So 4a minus a. So c is basically ln 3a. I want the solution of this differential equation in any form. So that is the solution in differential equation. It's ln theta minus a equals to minus kt plus ln 3a. That's part 1. Part 2. Given also that theta equals to 3a when t equals to 1 and show that k equals to ln 3 over 2. I think that's simple. Ln 3a minus a equals to minus k times 1 plus ln 3a. So ln 2a equals to minus k plus ln 3a, capital A. K equals to ln 3a minus ln 2a, and that gets divided. So I get k equals to ln 3 over 2. Then it says find theta in terms of a when t equals to 2. Theta in terms of a. So I need to make theta the subject when t equals to 2. So I will plug in 3. T equals to 2. Okay, this is really interesting. I need to plug in t equals to 2. That's what the question is saying. So this becomes ln theta minus a over 3a equals to minus 2 ln 3 over 2. So ln theta minus a over 3a equals to ln 3 over 2 power minus 2. And 3 over 2 power minus 2 should give me ln 4 over 9 because the minus will reciprocate, and I have theta minus a over 3a. The ln will vanish because I have an ln on both sides. I can get rid of it. Then I can cancel out this 3 and 3. So I have theta minus a equals to 4/3 a. Theta equals to 4/3 a plus a. Theta equals to 7/3 a. I hope that's the correct answer. Yes, that is the correct answer. Question number 9 says the number of insects in a population t days after the start of the observation is denoted by n. So dn over dt is modeled by this differential equation where k is a constant. It is given that n equals to, so they've given you the model of the differential equation. I don't need to create it. Remember that your calculator should be in radians. Let me just put my calculator in radians. Okay, solve the differential equation, obtaining a relationship between n, k, and t. So solve. Let's start solving. 1 over n dn equals to k cos 0.02t. It's easier when you keep k in the numerator. I could take it in the denominator as well, but that's going to make it a little complicated. So ln n, k comes outside, and sine this basically integrates to minus sine, no, sorry, sine 0.02t, it's not differentiation, divided by 0.02 plus c. So when n is 125, sine of 0 over 0.02 plus c. So c is basically ln 125. Obtaining a relationship, so ln n equals to k times sine 0.02t over 0.02 plus ln 125. That's a perfectly fine relationship between the two variables. You don't need to make anything the subject. Then it says, given that n equals to 166, find the value of k, 30. Okay, so ln 166 minus ln 125, k times sine 30 into 0.02 is 0.6. The entire thing is divided by 0.02. So I can then put everything on a calculator. I don't need to do this manually. I think I'm going to get a answer. Okay, so the calculator gives me a value that says 0.0100479. Okay, so approximately 0.0100, or I can say 0105. Either should be fine, since there's strictly three significant figures, so 0105. Okay, no, that should be 100. Oh, my bad. Okay, 005 if I want to write it. That's four significant figures, but the question's requirement is three significant figures overall on the exam, so you don't need to change that. Okay, obtain an expression for n in terms of t. So ln n 0.01 sine 0.02t divided by 0.02 plus ln 125. So 0.01 divided by 0.02 is basically half sine 0.02t. So this goes here, ln n minus ln 125. So that's n over 125 ln, and I have half sine 0.02t. I need to make n the subject. So n over 125 will be e power half sine 0.02t. N equals to 125 e power half sine 0.02t. Okay, and find the least value of n predicted by this model. Now, there are two ways of doing that. Either I could say that dn over dt equals to 0. So that could be done, or what I could also say is that the least possible value of this sine function could be -1. So 125 e power half into -1. Let's see if that gives us the correct answer. Okay, we've done this before in trigonometry, that sine takes on three possible values, and those are 1, 0, and -1. In this case, I'm using -1 because I'm trying to find the least possible value. Yeah, I think that should work. Yeah, let me just check with something. Okay, I've done something wrong here. E power minus 0.5. Okay, yeah, 75 75.8. Is that the right answer? It's giving me 75.6. I think that's a rounding of error somewhere that I've done. Um, Based on the fact that I took 0.0100. If I had taken 0.01005, let me check if the answer becomes more accurate. And that is what I should be taking. Okay, so e power minus answer into 125. Yeah, it becomes more accurate when I take it as when I use it in the next part, I should be taking 0.005, and that gives me 75.6 at the end. But I think that answer should be negligible. It shouldn't be a problem on the exam. Okay, so this was okay. So question number 9 says the rectangular reservoir has a horizontal base of 1,000. So I'm going to draw this small shape here and say that this is a horizontal base that I have. Okay, this is a horizontal base, that's 1,000. Okay. At time t0 it is empty, so v equals to 0 when t equals to 0 and begins to flow into it at a rate of constant rate of 30. So what is coming in? So dv over dt is positive right now. At the same time, water begins to flow out at a rate proportional to root h, so it's also flowing out. So it's k minus k root h. Where h is the depth of the water when h equals to 1, dh over dt equals to this, so that h satisfies the differential equation. So I know that I can't go from dv to dt, from dv to dt to dh to dt directly. I need a connection, and that is the chain rule. So I'm going to say that this is cuboid. The volume of a cuboid is length into width into height. I don't have the length and width right now, but I can say that it's simply going to be the base area multiplied by the height. So that's 1000 h. Can I differentiate that and say that dv over dh will basically be equals to 1000 when h gets differentiated? How does that help me? I can then construct a chain rule and say that this is dv over dt over dh over dt. So 1000 equals to dv over dt is 30 minus k root h, and dh over dt is something that I'm trying to find. So that gives me dh over dt equals to 30 minus k root h over 1000. I hope the units are the same as what I want them to be. Yes, they are the same. So h equals dh over dt equals to 0.02 and h equals to 1. So 0.02 30 minus k into root 1 over 1000. So 20 equals to 30 minus k equals to 10. So dh over dt is basically equals to 30 minus 10 root h over 1000. I can pull out a 10 common. 3 minus root h over 1000, and I get 0.013 minus root h as dh over dt. So I've shown, okay, that is what I wanted to show. It is given that after making the substitution, so I'm now asking you to substitute. The equation in part 1 becomes this. Okay, so I am going to differentiate. I'm going to plug in my replacement first, and x is equals to 3 minus root h, so this is going to become 0.01x. But at the same time, I know that I don't need h anymore. I need dx over dt. So if x is 3 minus root h, can I differentiate this and say that dx over dh? That's the answer to part 1. That's where I started part 2 from. Okay. I can't replace this. So what I'm going to do is I'm going to first differentiate and say that this is dx over dh. That gives me, now just writing this out clearly so that you can see. So that's 0 minus half half minus 1. That gives me minus 1 over 2 root h once I simplify. So dx over dh is this. I need to replace dh. So I'm going to say that that is 2 root h with a negative dx equals to dh. Okay. Further, what happens is I was at this point, dh over dt equals to 0.01x. I had replaced 3 minus root h with x. Dh gets replaced with minus 2 root h dx over dt equals to 0.01x. Again, I don't need h in my proof, so what I'm going to do is I'm going to make this the subject, so x becomes root h becomes 3 minus x. So I'm going to get minus 2 3 minus x dx over dt equals to 0.01x. In the proof I have x minus 3, so I'm going to multiply that inside and say that x minus 3 times 2 is dx over dt 0.01x. Then I also don't need the 2. I'm going to take that to the other side and divide and say that this is my answer, 0.005x and x minus 3 dx over dt. So that's what I've proved to you. Then it says using the fact. Oh, this wasn't even part of the question. I've gone ahead and proven it to you. But using the fact that x equals to 3 when t equals to 0, solve the differential equation, obtaining an expression for t in terms of h. So all this didn't really wasn't really part of the question. I didn't read it carefully, therefore I went on and proved that to you. In any case, so I need to solve the differential equation. That's part 2. X minus 3 over x dx equals to 0.005 dt. Okay. Then integrating on both sides, this becomes 0.005 t plus c, and I'll have to separate this to get my answer. So 1 becomes x minus 3 ln x equals to 0.0005 t plus c. Okay. So obtaining an expression for t in terms of x. So x equals to 3 when t equals to 0. 0 plus c. So c equals to 3 minus 3 ln 3. And I need to make t the subject. So x minus 3 ln x. Okay, moving everything to one side to make t the subject. 0.005 is basically 1 over 200. So that's going to be t equals to 200 into x minus 3 ln x minus 3 plus 3 ln 3. Okay. Yeah. So find the time at which the depth of the water reaches 4. So the only thing that I need to do in the last part is plug in 4 or 3, sorry. 4 minus 3 ln 4 minus 3 plus 3 ln 3 equals to t. 27.4. Uh, oh, okay. The depth of the water reaches 4 meters. So that's not x. The depth is basically h. Let's do that. X equals to 3 minus root h. So 3 minus root 4 x equals to 3 minus 2, which is 1. So 200, 1 minus 3 ln 1 minus 3 plus 3 ln 3. Okay, 1 minus 3, 3 ln 3 into 200. It's 259.167. So 259 seconds. Moving on to the last question. This is question number 10. It says an underground storage tank is being filled with liquid as shown in the diagram. Initially, the tank is at the depth of this. At time t hours after filling the tank, the volume of the liquid is V and the depth of the liquid is given by this. The liquid is poured in, so water is coming in at a rate of 20. But owing to a leakage, the liquid is lost at a rate proportional to kh square. When h equals to 1, dH over dt equals to 4.95. Again, I have dV over dt. I need to come up with a chain rule that will help me solve the problem. So there is the volume. Yeah. Can I differentiate this to find out 12 over 3 h square? So 4h square. So dV over dH equals to dV over dt or dH over dt. So dV over dH is 4h square. dV over dt is 20 minus kh square divided by dH over dt. So dH over dt is then 20 over 4h square minus kh square over 4h square. I get dH over dt as 5 over h square minus k over 4. I can solve for k. Okay, so 5 minus 4.95. That's 0.2. So dH over dt is 5 over h square minus 0.2 over 4. That is 1 over 20. Then that was part 1. Part 2 says that verify that this is equals to that. I can verify in whichever way I want. I can take the right hand side and equate it to the left hand side, or and prove that it's equal to the left hand side, or take the left hand side and prove that it's equals to the right hand side. Okay, so I'm just going to use, I don't think I should go on and use partial fractions, so I'm just going to say that I'm pricking out the right hand side, and I see 100 minus h square in the denominator. It's a minus b into a plus b. So when I take a common denominator, I get minus 20 100 minus h square plus 2000. So minus 2000 plus 20h square plus 2000, or 100 minus h squared. So I've proved. Okay, there's just one mark, so that's pretty much it. Then part 3 says, hence solve the differential equation in part 1, obtaining an expression for t in terms of h. Okay, so this is a little time consuming. Why? Because I start off with my differential equation here. When I take an LCM, I get 20h squared, and this becomes 5 into 20 is 100, 100 minus h squared, dH over dt. Then 20h squared over 100 minus h squared, dH, and 1 dt. Now, this is a question then on partial fractions where I have an improper fraction because the numerator and denominator both have a square. Luckily for me, this has already sort of given me a hint that I need to do this. So I'm going to say that this gets replaced with minus 20 plus 2000 over 10 minus h into 10 plus h. Sorry, into. And the other side becomes t plus c. So for partial fractions, I'm going to do the normal process. 2000 over 10 minus h into 10 plus h equals to a over 10 minus h plus b over 10 plus h. That gives me h equals to minus 10 first, 0 plus 20b, b equals to 100, and then 2000 so h equals to 10 for cover up. I've taken both as 10. So 2000 equals to 20a. So a is also equals to 100. Then for integrating, I'm going to write down minus 20 plus 2000 over 10 minus h into 10 plus h. Both of those came out to be 100, and I had gotten t plus c here. So I'm going to say that minus 20 gets integrated to minus 20h. There's a dh here. And this actually breaks down into two partial fractions, 100 into 10 minus h and 100 into 10 plus 100 over 10 plus h. And then when I integrate both of these, I get minus 20h plus 100 ln 10 minus h over minus 1 plus 100 ln 10 plus h equals to t plus c. Okay. Then I need to find out c. So h equals to 1. Okay, it doesn't say anything. Initially the tank is empty. So t equals to 0 and h equals to 0. So minus 20 into 0 minus 100 ln 10 plus 100 ln 10 equals to t plus c, 0 plus c. So c comes out to be 100 ln 10 minus 100 ln 10. So c is 0. Then I have my final answer as minus 28 minus 100 ln 10 minus h plus 100 ln 10 plus h equals to t. Is that what I wanted? T in terms of h. I can go on and make this a little more compact by saying that I could, pull out 100 common, and then I would have 10 plus h minus ln 10 minus h equals to t. So minus 20h plus 100 ln 10 plus h over 10 minus h, and that is the final answer. Yeah. Okay, that brings us to the end of this marathon. Please make sure to like and subscribe if you like this video, and please ask your questions in the comments. Thank you.